Can ocean acidification dissolve mollusk shells? Imagine a world where the shells of clams, oysters, and mussels start to weaken or even disappear. That's what scientists are studying with ocean acidification. When carbon dioxide from the air gets absorbed by seawater, it makes the water more acidic. This change in water chemistry can cause big problems for marine animals with shells made of calcium carbonate. Calcium carbonate is a mineral that forms the hard shells of many invertebrates. When the water becomes more acidic, it reduces the amount of carbonate ions available. These ions are what mollusks need to build and repair their shells. Without enough carbonate, shells can become thinner, weaker, or even start to dissolve. Tiny sea snails called pteropods are a good example. When they live in more acidic waters, their shells show signs of pitting and erosion. In some places, over half of these snails have shells that are visibly damaged. This makes them more vulnerable to predators and harsh environmental conditions. Not all mollusks respond the same way. Some species can change the type of calcium carbonate they use. For example, they might shift from aragonite, which is strong but dissolves easily, to calcite, which is more stable in acidic water. California mussels are doing just that. They now produce more calcite in their shells than they did decades ago. Still, their shells are not as sturdy as before, which means less protection from waves and predators. Young mollusks are especially at risk. Oyster larvae need to grow their shells quickly after hatching. If the water is too acidic, their shells can dissolve before they are fully formed. This has caused big problems in oyster hatcheries and affected wild populations. Even though some mollusks try to adapt, the overall trend shows that ocean acidification makes it harder for them to build and keep their shells. This can lead to fewer mollusks in the ocean, which impacts many other marine animals that relying on them for food and habitat. So, yes, ocean acidification can dissolve mollusk shells, especially in vulnerable species and at early stages of life. The extent of this effect depends on the type of mollusk, the minerals in their shells, and local water conditions. For marine life, this means more challenges in survival, growth, and reproduction, which could shake up entire ocean ecosystems.